now. Okay, we should be recording now. Where's that? There it is. Okay, so what did you do? Which way do you want a number? Why?
Because one is a double bond on there, and on the other side, does that take precedence? It probably does. I forget my.
That's all right. Write it down now. Okay. Oh, looky here. I'll change the color. Maybe I'll change the color. Okay. So we're numbering from the right, correct? All right. So did everybody get 9? Make that skinnier. Okay. So what do you want to do? No idea? No, nah. Remember E9? Okay. So what numbers go? What number goes here? What numbers go here? 2 and 6. What numbers go in the front? 4 and 8. Okay. What else do we need? Yeah, for this one. Okay. We also refer to this as E9, oh. You don't get it? Oh, God. All right, that was your joke for National Periodic Table Day. Yesterday was National Periodic Table Day. The periodic table is 150 years old. 150. Okay, wait a second. There we go. I'm like, there was a question next. What did I do? Okay, I gotta make it smaller because it just didn't all fit. There we go. Is that okay?
Sometimes I want to pick E just.
You just want to pick E just because? Yeah. I can understand.
Like our last question ever.
Okay. There won't be so many. Okay. I had somebody in physical science pick one. He said, I just had to pick Star Wars just because. He said, I'll only do one, but I just had to. It was funny. All right, how many of you are there? 1, 2, 3, 4, 5. I got 15. That's right. Everybody's up there? All right, so we're going to look at this carbon right here. How many carbons are directly attached to it? So it doesn't matter that these guys are holding hands back there. Okay, that doesn't matter. Okay? Okay, acidity of alcohols and phenols. Remember what a phenol is? Benzene ring with an OH. Right there. There's one. Phenols are more acidic than regular alcohols. Why? Okay, they're quite a bit more acidic than regular alcohols. If you look at the pKa numbers over there, you'll see that the pKa of phenol is 10, and the pKa of ethanol is almost 16, rounded to 16. Okay, so why? What is different? Okay, here is cyclohexanol. You'll notice that it's 18. Okay, so it's not the ring. What is it? What? Those double bonds. And what can you tell me about this? All right, I tried to put 3 lone pairs on there. Okay, on the phenoxide anion, what can you do? Everybody see something? You can stabilize it by resonance with the ring. Okay, that is going to make a big difference. You'll notice that this one up here is 2-chloroethanol. That's the second one. What about adding a chlorine on there? What does that do to the acidity? Did it go up or down? Molar pKa, more acidic. It went up. It's more acidic. Okay, why? What is the chlorine doing? It's electronegative. It's pulling electron density towards it. So when you got this, okay, there's 3 lone pairs there. That was the point. Okay, the negative charge is being held in by the chlorine over here. It's pulling the electron density toward it. This, though, is a resonance effect. Okay, resonance is a much greater effect. Okay, what if I put this compound here? Do you think that would be more acidic than phenol or less acidic? What did I do? I put what on there? A chlorine, which is going to do what? Pull electron density toward it because it's electronegative. So what's that going to do to the ability or the acidity of that proton? Its ability to be plucked off. It will be easier. So this will be more acidic than anything that's up there. I don't know what the pKa. I don't have very many of those memorized. Okay. Organometallic compounds contain a carbon-metal bond. Okay. Get it? Organometallic. Yeah. Sometimes we make sense. It's amazing. All right. So the CX bond is reversed when X is replaced with M. M stands for, what do you think? Metal. Okay. What does X stand for? Halogen. Okay. So for example, if you take an alkyl bromide and you add lithium to it, you end up making a compound that's referred to as an alkyl lithium. You do have to be careful when you do this. Lithium wants to react with water, so you need to make sure your stuff is nice and okay. So if you can also do this with benzene rings. Okay, so that's chlorobenzene, and you get this one, PHLI. Okay, so what we've done is we have taken this bond and we've changed it to this bond. Okay, so our CBr bond is polarized, agree? Which way is it polarized? To the bromine or to the carbon? Who wins? Bromine wins, okay? But when we put that lithium on there, it's polarized the opposite way. So this is negative and this is positive. You can even think of it as being kind of exciting. Almost a full ionic bond. okay, because it's a nonmetal and a metal. Okay, the same thing is true when you make organomagnesium compounds. These are called Grignard reagents. Okay, notice the difference between making a Grignard reagent and making the alkyl lithium. You add the magnesium, but does it replace the bromine? It goes in between. It inserts itself in the bond. Okay, so instead of this, we're now going to have this, where it's in the middle. Well, if you look at the periodic table, okay, what column is lithium in? Column 1. Okay, it's element 3, right? All right, where is magnesium? It's in column 2. What's column 1 referred to as? The alkali metals. What is column 2 referred to as? The alkaline earth metals. Okay, do you remember anything about the charges they like? The first column likes to make what charges? +1, and the second column likes to make +2. Okay, notice that magnesium is in the second column, it has 2 things on it. All right, so maybe that'll help you remember. I don't know. Okay, but once again, this bond is going to be polarized the other way. Okay, and this is a way, using these organometallic compounds, that we can make carbon-based nucleophiles. Okay, how did we make carbon-based nucleophiles in the last chapter? Sodamide plus acetylene, or terminal alkynes, did it. Okay, we did an acid-base reaction. Now we're throwing a metal ion in there, and we're not limited to triple bonds. Okay, it can be a whole slew of compounds. So we'll make lots of them. Okay, if you take an alkyl lithium or a Grignard reagent and you react it with an epoxide, it goes to one of the carbons, and then you open your ring. Okay, does that look familiar? We had epoxide and we protonated it, and our nucleophile came in and we opened it. Okay, this is the same thing, except this time you're forming the O-. There is no acid in there when you do the reaction. There can't be any acid or any alcohol or any water. Okay, because this would get protonated instead. Okay, so you do this part first and then you add the acid. It's another step. Okay, here we have a Grignard plus ethylene oxide. It's probably the simplest oxide you can have. Okay, and then we protonate it, and look what we did. So we started with 2 carbons, and now we have 4 plus OH. Okay, what if the epoxide was not symmetrical? You'll notice that in both of those examples, the epoxide was symmetrical. Okay, so what if, there we go, I got it. We took and added it to this one. Ooh, go away. I was just trying to put 2 lone pairs on the O just because. Okay, what would happen? Okay, this is still going to serve as your nucleophile, but which side do you think it will go to? The CH2 side. Okay, it's going to go here and open there. Okay, when we did the other reaction that went to the more highly substituted carbon, it went to that carbon because there was a plus charge. You'll notice that this epoxide is neutral. There is no plus on the O. Okay, that changes things. This goes to the least sterically hindered carbon. Okay, so unless you do acid first, it won't go to the it'll go to the more highly substituted carbon. But if you have your epoxide and it's neutral, the nucleophile goes to the least sterically hindered epoxide. If you wanted it to go to the other one, you would just have to make it a whole different. You couldn't make it this way. All right, so what would you get now after this step? Let's finish the whole thing off. Okay, so I now have a bond between here and the methyl. Okay, and what is with this carbon over here in the left? It's going to have an O minus, Li plus, that's going to be your counter ion. Okay, and then if you add acid to that, you will make an alcohol, right? So if you start with, say, a cyclohexyl lithium, okay, look at how complicated you can all of a sudden make things within just one step. Okay, you can make a variety of things. Okay, if you take an alkyl lithium or Grignard and you react them with an alcohol, the alcohol simply protonates it. Okay, you're going to end up doing an acid-base reaction. So you put an extra hydrogen here. What if you got sneaky and you used a deuterated alcohol like this? Okay, so what's D, y'all? Deuterium. What is that? It has one proton and one neutron. Okay, heavy hydrogen. Regular hydrogen, the most common one, only has a proton. It doesn't have a neutron. Okay, so if you do this, now look what you did. You labeled that spot with a deuterium. So you can do that on purpose, okay, to put a deuterium in a specific spot. Let's say you made a drug and you want to take that drug and test it and see what happens to it. Where does it go when it gets metabolized? Does it go into the liver? Does it register in the spleen? Where does it hang out? Okay, well, you can label it at specific spots, put a deuterium on there, and then see where that ends up. Okay, after your little rats have eaten. You do have to kill the rats. Yeah, I don't do that stuff. I just make the compounds. How's that? Okay, you could also use D2O to protonate them, or ROD. It just depends what you have. Okay, D2O is pretty easy to get, come by. And you can deuterate your alkyl lithium or Grignards. Notice where the D ends up. It ends up where the alkyl lithium or the lithium or the magnesium are. Okay, on that carbon. It doesn't just end up on an end or something. Okay, does that make sense? All right. Okay, we're going to take those Grignard reagents and we're going to react them with other things besides epoxide. That is only the beginning. The Grignard reagents is one of my favorite reactions because you can do so much with it. Okay, so we're going to react with formaldehyde, aldehydes, and ketones first. Okay, all of them have something in common. Okay, so if you look at formaldehyde, how about a regular aldehyde? How about a ketone? It does not have to be symmetrical. So I'll put R prime, meaning that it can be different. Okay, what do they all have in common though? C double bond O. What is that called? It's called a carbonyl, right? Okay, okay. So what can you tell me about carbonyls? Look at that, I'll even do that for you. Okay. Are carbonyls polarized or non-polarized? They polar bonds or non-polar? What do you think? Look at the period. What do you think? Are they polar or non-polar? Well, what's a regular CO bond? It's polar, right? This is more polar than that. Okay? This is highly polarized. Who gets the negative charge? The C or the O? The O. Why? Because it's more electronegative. Okay, so this is delta plus, delta minus. Yeah, that was a plus. Okay, you'll notice that if you have a carbonyl, here I'll just use formaldehyde so you have a whole compound there. Okay, you can draw a resonance form for it. Okay, so how would you do that? How would I draw a resonance form for that? Where do you want me to start? What you thinking? Not much, it's Friday. Haley's hugging the weekend over there. Okay, so what are we going to do? Are we going to go from the O in? Why can't we do that? What would happen to that carbon? It would get how many bonds? Too many. So which way do we got to go? We got to start at the pi electrons. Are we going to go to the C or the O? The O, because it is more electronegative. Okay, so we're going to get man, this thing is like off to the max. Okay. All right, and then up here we have this. So I took those 2 electrons and I put them out on the O. We didn't violate any octet rules, did we? But what are we missing? Charges. What do we get? What does the O get? Negative. What does the C get? Positive. Are you positive? Are you positive? It's positive. Okay? Notice the net charge over here is 0. The net charge over there is 0. Okay? It's probably been a while since you thought about that. Okay? So, if you are going to be a Grignard reagent, where on formaldehyde are you going to react? What do you think? So here's my Grignard reagent. I will use this one because I like it. Okay, and how do you make that? You take bromobenzene and what do you add to it? Magnesium. Okay, and we normally do this in dry ether. Okay, so we're going to take that and we're going to add it to formaldehyde. Okay, I got the electrons on there this time. Okay, now what happens? Where do we go? Where on the, what can you tell me about the carbon that's attached to the magnesium of a Grignard reagent? What is its delta? Delta what? Negative. It's negative. Negative goes to positive. So where am I going? Which carbon? The carbon of the carbonyl. Can I stop there? No, because that bond, that carbon would get how many bonds? 5. Does carbon get 5 bonds? No. All right, so what are we going to do? We're going to go to the O. Follow through. Okay, so what did I make now? At this point, I have a benzene ring, just because that was what I picked to use. Okay, and it's bonded to the carbon of the formaldehyde. which has two H's and an O, what? Minus. What is the counterion for the O minus? Well, what's left from the Grignard? MgBr. So you get MgBr plus is your counterion. You might need to know that in the homework, in the sapling. Okay, I'm not overly hyper about it personally. Okay, now that's not the end product because we're going to add acid to that. Okay, so if we add H3O plus, typically we use sulfuric acid to do this. That's pretty standard. What will the arrows be? The O minus is going to go and grab a proton. What happens to the electrons in the OH bond right here? They go to the O. So what are we going to make? Here's what didn't change. Okay, so what do we do to the O? We put a H on it. Okay, what did we get from the H3O plus? We got water, little water, agua. Okay, all right, now a couple things I want you to notice. What is the hybridization of the and geometry of this carbon? What is it? The one that I marked with red. It's sp2. What is its geometry? Trigonal planar. Remember those nice, easy questions? Okay, look at this little intermediate that's formed. What is the hybridization and geometry of that carbon now? sp3, and what is it? Tetrahedral. Okay, this is often referred to as the tetrahedral intermediate. See how we get that? Okay, that's how come. It changes. It's still tetrahedral at the end. Whenever you add a nucleophile of any kind to a carbonyl, you go out to the O. You go to the C, you go out to the O. Okay, so always do the follow through. If you hit the tennis ball and you don't follow through, you don't get a good hit. It goes right into the net. Ask me. Okay. I'm not a very good tennis player, although I tried. Okay, wait, we're not done. We got to do some more first. Let me go back. There we go. All right, so I got to go insert a blank page. Okay, so I'm going to start with the same Grignard reagent every time so that I don't have to make it every time, but I'm going to react it with different compounds. Okay, so here's my Grignard reagent. Okay, and I'm going to add it to this compound, which is commonly referred to as acetaldehyde. I'm picking a simple one. Okay, so what happens in this reaction? What can you tell me about this carbon right here? It's going to be the nucleophilic carbon, right? Where does it go on acetaldehyde? Where's it going to go? Which carbon? There's two. This one, the carbon of the carbonyl. And then you gotta follow through, okay? All right, so can you draw what you have now after that step? And I don't care if you draw your benzene ring, if you write pH, that's okay. Okay, what else do I need? What does the O get? A negative, because it has how many lone pairs on it now? 3. What's the counterion? MgBr plus. This is actually formed in the reaction. Okay. And then after that part is done, then and it takes about a half an hour to do that part, making the Grignard takes sometimes a couple hours. Okay, then you will add your acid. That's an arrow, honest. Okay, so can you draw those arrows? The protonating arrows, the protonation step. So one of those lone pairs goes to one of these hydrogens. It doesn't matter which one you pick, they're all equivalent. And then what happens to the electrons in the OH bond? They go to the O. Okay, so what do we get? Well, here's our benzene ring. It's attached to a C with a methyl and a hydrogen and an O and what else? An H. Okay, and we also made H2O. I only worry about that when you're doing the mechanism. If you just have to write the product, all we worry about is organic products. Okay, what about that MgBr plus? It just becomes ions in there and you wash it away. It's kind of nifty. Okay, what kind of alcohol did we make this time? Classify it. That's why we did that earlier. What kind of alcohol did we make? Secondary. What did we make on the formaldehyde one? Primary. Okay. All right, now we're going to add a ketone. All right, so I'm going to start with my phenyl magnesium bromide. That is the technical name for it. And I'm going to add my simplest ketone of acetone. Okay, so can you draw the arrows and write out all the stuff? I bet you can do it. You've done it a couple times now. So you write it out and then I'll write it out and then you can see how you're doing. And then we're going to add H3O plus. They could write H3O plus or they could write H plus and H2SO. Like see that. I've seen both of those. But it's always sulfuric acid. So you can do the next step and add the acid too. Okay. Okay. So I'm going to write it out up here. Okay, and then we're going to add H. Okay. And then I want you to tell me what kind of alcohol we made. What kind of alcohol do we make? Tertiary. Okay, so to summarize, if you have a Grignard plus formaldehyde, do you remember what that is? What kind of alcohol do we get? Primary. Okay. All right. A alcohol. I'll squeeze it. Okay. If you have a Grignard plus an aldehyde. Okay, that would be RCHO. Remember, CHO stands for the aldehyde, carbonyl H. okay, you would get what kind of alcohol? Secondary. If you have a Grignard and you add a ketone, that would be R carbonyl R prime. They don't have to be the same. You could have a methyl and L, okay? But you would always get a tertiary alcohol. Okay, so I want you to remember, the carbonyl is polarized, the carbon end is plus. The nucleophile will thus attack the carbon nucleus. A Grignard makes an alcohol of types there are but 3. It makes a bond to correspond from C to shining C. You got it? You take a Grignard plus a carbonyl compound to make an alcohol, not a Grignard plus an alcohol to make an alcohol. Okay, that's the most common thing I see. You take a Grignard plus an alcohol, you just protonate it. Okay, you got to have that carbonyl in there. Okay, I realized that that was not recorded. Oh my gosh. Okay, so we're going to make 2-heptanol using a Grignard reagent before we do these. Okay, we're going to make 2-heptanol using a Grignard reagent. So I want you to go backwards, your favoriteest thing. All right, so here we go. We're going to add in another blank page. So 2-heptanol. You had a lot of paper with you today, right? Okay, 1, 2, 3, 4, 5, 6, 7. Gosh, we had Old MacDonald and Seed is Shining Soup again. All right, 2-heptanol. What kind of alcohol is that? Classify it. What? Secondary. So we're going to take Grignard, and what kind of compound are we going to add to it? An aldehyde. Okay, so keep all that in mind as we figure it out. Okay, the carbon that's attached to the OH, this one right here, where did it come from? Where did that carbon come from in the pieces that you put together? Did it come from the Grignard or did it come from the aldehyde? Everybody see that? That is where we went out to the O. Okay, so I'm going to split this molecule into 2 pieces. One piece will come from the carbonyl compound, and the other piece is going to come from the Grignard. Okay, so where do you want me to split it? Between carbons 2 and 3. Perfect. Okay, so I'm going to use green. I'm going to split there. Okay, so what Grignard reagent do I need with the green? We're going to call it the green root. Okay, so what Grignard do I need? What Grignard reagent? How many carbons? 5. 1, 2, 3, 4, 5 mGbr. Make sure that you've got 5 carbons. 1, 2, 3, 4, 5. Okay, make sure you got 5 carbons.
Why didn't you do it?
Why didn't I do a cyclo? Because my compound is all straight carbon.
Oh, that's good.
Yeah. We'll do one like that though, Jessica.
Okay.
Yeah. I wouldn't want you to not get to practice this up. Yeah. All right, now what carbonyl compound am I gonna use? Okay, how many carbons is it gonna have? 2. It's from the left side of that little green line. So I'm gonna write CH3, what? C, CHO, or carbonyl H. You could write CHO, there's nothing wrong. But if you want to draw out the little arrows, it's easier if you draw the carbon. Okay, so to draw out those little arrows, where do I start? The carbon attached to what is the nucleophilic carbon? the one attached to the magnesium. It's this guy right here, okay? So I'm going to go from here to the, where? The carbon of the carbonyl. And then I go out to the O. Okay, so what do I get at this point? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that is now attached to the, and that has on it a methyl, a hydrogen, and an O. Okay? Okay, where do those electrons go now? They're on the O. Okay, the O gets a minus. Okay, and what else we need? MgBr plus. Okay, now your next step will be to add what? H3O plus. And guess what? We made that. Okay, now we're going to go back. And I'm going to ask you, how do you make the Grignard reagents? You can buy them, but they're really hard to work with because they'll get protonated by moisture. Okay, so it's tough to buy them. Everybody makes them. Okay, unless you're just nuts, I guess. I don't know. We always made them when we needed them. Okay, so what am I going to make that Grignard reagent from?
It's going to be a.
And how many carbons? 1, 2, 3, 4, 5. And what am I going to have over here? A bromine. Okay, and what is my reagent? Yeah, pretty much. That's it. Magnesium. It either is going to be an ether or THF. Ether is the most commonly used one. When you buy ether, it comes nice and dry. So like to do this reaction, you have to use a brand new can. Because as soon as you open the ether can, it'll start picking up moisture, especially in humid Oklahoma. So typically we would do a brand new can, start from scratch. That can be used for other things later on, but it can't be used for Grignard once it's open. Okay? All right, now there was another way to make that. This is method 1. This is the green route. How else could you make it? You have any ideas? There's often going to be more than one correct answer for things. Okay, so what is the other one? Remember that the carbon of the OH, that the OH is on, come on. Okay. 1, 2, 3, 4, 5, 6, 7. Okay, this carbon here comes from the carbonyl compound. Does the carbonyl compound have to be the left side? Couldn't it be the right side? Okay, so what if I split it there? Okay, what would be your Grignard reagent now? A methyl. Yeah, just a methyl. Okay, and what would be your carbonyl compound? What's going to be over here? How many carbons? How many carbons? 6. Okay, 1, 2, 3, 4, 5, 6. And notice it's still an aldehyde. Okay, so where is your nucleophile in your Grignard? It's the carbon that's attached to the magnesium. Okay, and it's going to go to the carbon of the carbonyl. Okay, so what do we have now? That exact same thing. We just made it a different way. Which one would you do? You would do whatever compounds you had in your lab, probably. Okay, in order to make this Grignard reagent, what would you need? I'll give you a hint. With a bromine, right. And what goes on the arrow? That's step 1. Step 2 is adding the aldehyde. Okay, what do you have after step 2? I guess I didn't draw it all out. Okay, and then step 3 is going to be adding the acid. And this literally is done in 3 steps like this. Okay, you don't throw it all together at once. If you do that, it won't work. Okay, you got to get the Grignard made, you got to add your carbonyl compound, wait about half an hour to an hour, and then add the acid. Okay, but you can make a variety of stuff. Okay. Okay, so for next time, what I want you to do is figure out how would I make using a Grignard okay? That's what you want to end up with.
Does the second wave might have like a
No.
just the second way, this is the other way.
Yeah. Oh, I guess it should be the blue route. Because I did it in blue, right? Yeah.
Oh.
Other than that, it doesn't have it. I only named that the green route because I was being weird.
Yeah, blue root.
Yeah, you've ever been in the subway and you gotta follow, they're always color codes.
That's good. I've never found out.
Uh-huh.
It's scary.
I like that.
Hey,
That's why I was like,
Well, did you, there was a few pages in there. Did you not give me, you're telling me you missed a page?
no. I'm saying like that's what all the people were.
Oh,
Then I
okay.
will
I'm
be
good as
fine.
long as it's all in there. I'm
Okay.
fine. Because I'll look when you miss.
Okay.
Okay,
All right.
I'll look and make sure.
And I'll
it's in there.
remind you.
Okay. Okay. Yeah, no worries.
Okay. I'm just thinking.